Hello, welcome. This is Mr. Los. We're going to continue our series in organic naming. We're going to name esters and ethers today. I think these are some of the harder ones. In particular, ethers are the ones that I found that students have the most difficulty with. So first, let's jump right into the esters. So what characterizes an ester is a carbonyl, carbon double bonded to oxygen, and then another oxygen right next to each other on consecutive carbon atoms, or consecutive atoms. So these are named a little differently. We're not going to try to find necessarily the longest consecutive chain of carbon atoms. Esters get their name from, they're made, as we'll talk when we talk about organic reactions, they're made from an alcohol and a carboxylic acid coming together. So the best way to do it for now is think of the ester as in two parts. The part that sort of ends in the carbonyl and the part that ends in the oxygen. And the part that ends in the oxygen is going to get a YL ending, it's named with a prefix, and the part that ends in the carbonyl is going to get an OH ending. And so, for example, here there's just one carbon for the oxygen, so that's methyl, and then 1, 2, 3, 3 carbons, including the carbon in the carbonyl, so that's methylpropanoate. Let's look at a couple of more examples. So here on the left of the screen, we have several more esters, and again, always the carbonyl next to the oxygen. So, like comparing these two and looking at these two. So, I'm seeing the oxygen, and I'm taking this molecule in two parts. We got this part here that ends in the oxygen, and we got this part here that ends in the carbonyl. So, the part that ends in the oxygen is going to get the YL ending, and it's going to be a prefix, and the part that ends in the carbonyl is going to get the OH ending. So, 1, 2, methyl, 1, 2, 3, 4, butanoate. Let's just double check that with our naming system, our naming little checker here. Did I say methyl? I think I did say methyl, but there's two, so it would be ethyl. Sorry about that. Okay, so here we have 1, 2, 3, 4. That would be, and here's the oxygen. So this part is going to be the YL part. It's going to be butyl. And then this part that ends in the carbonyl is going to be an ethanoate. Now, this will probably name this using the more old-fashioned system and call it acetate. Yeah, butyl acetate. The official IUPAC name would be butyl ethanoate. So I think either one is probably okay, but IB would always say butyl ethanoate. So here we have another example. So again, we're looking at the part that ends in the oxygen. There's only one carbon there, so that would be a methyl. 1, 2, 3, 4, 5, 6. 6 carbons, including the carbon in the carbonyl. So that's going to get the OH ending. That's going to be a hexanoate. So methyl hexanoate. And there's your esters. Now ethers. Let's take a look at those. When you have an ether, you have an oxygen in sort of the midst of a carbon chain. And there's a variety of ways to approach and think about ether naming, but what I think is pretty good is to sort of think of the ether as a functional group that is going to be that, and this functional group has an oxygen and a certain number of carbons associated with it. So if there was one carbon, it would be methoxy. If there was 2 carbons, it would be ethoxy. If there was 3 carbons, it would be propoxy, and so on. And so we're going to think about it as a functional group with that sort of name. And other than that, it's going to more or less work like the other functional group naming that we've talked about. And again, this one is going to be a little different, that we're not going to necessarily try to find the longest uninterrupted chain of carbons, but we are going to look for that, but we're also going to look for this methoxy, this ether functional group. So, for example, so I see 1, 2, 3, 4 carbons here. So we're going to consider this to be kind of the main chain because it's the longer one. And so this is going to be named as a butane. And then we have this little CH3 with an O. So if we were going to number these carbons, kind of like we would, we're going to give this carbon numbering priority. So this is going to be carbon 1 right here. It's carbon 1 in the chain that does not include that oxygen. You can think of the oxygen as kind of interrupting the carbon chain, right? So it's a butane. And then if we see associated with the oxygen here to the left of it, there's 1 carbon, so it's methoxy. But we also need to say where that methoxy is attached to, because it's possible that it would be attached to somewhere else. So just like with other functional groups, we're going to say that it's attached to carbon 1 in this case. So that would be 1-methoxybutane. As opposed to this one next to it. Notice 1, 2, 3, 4. So 4 carbon long chain that's not interrupted by any oxygens. So again, we're going to think of this ether as a functional group, and since this particular ether only has 1 carbon associated with it, on the opposite side of the oxygen, so to speak, that's going to be a methoxy, except this one's 2-methoxybutane. So notice the difference between those. 1-methoxybutane is on the end of this 4 carbon long chain. 2-methoxybutane is attached to the middle of it. And then there's other carbons further than that. So let's look at another few examples here on this. Okay. So again, these first two are very similar to the one that we just looked at. So the longest carbons I can count here without being interrupted by an oxygen is 5. So we're going to consider this the main chain, so it's like a pentane. And then we're going to think of this ether as a functional group, and this particular ether with oxygen is associated with 1 carbon that's on the opposite side. So it's a methoxy, and it's also on the second carbon. So since it's a pentane, it's 2-methoxypentane. So there's a pentane, and then there's this little thingy here that we're going to call a methoxy, and it's on carbon 2, giving it the lowest number possible as usual. Contrast that with this one. There's still 5 carbons in a row. That's the most that we can count that's not interrupted by an oxygen. So we're going to think of this as the main chain, and then we're going to think of this as a little methoxy functional group, and it's attached to carbon 1. So 1-methoxypentane and 2-methoxypentane are similar, but where the ether is attached is different. This one, it's on the end of the chain, and this one, it's on the second carbon end. So let's look at another one. Okay, so 1, 2, 3, 4, 1, 2. So if we, it's a little bit ambiguous. Which one's the functional group? Which one's the main chain? Well, we're just going to consider the longer one the main chain. This is going to be some kind of butane. And then notice how there's 2 carbons here associated with the oxygen. So instead of methoxy, this is going to be ethoxy. Still, though, we're going to say where the ethoxy is attached. It's attached to carbon 1 in this molecule. So this is 1-ethoxybutane. Compare that to the second one. 1, 2, 3, 4, 5, 6. So the longest carbons I can count are 6 that are not interrupted by some kind of oxygen. So we're going to think of this as the main chain, so it's a hexane. And then we have this, which is an oxygen and 2 carbons. So that's going to be an ethoxy group. And we got to say where it is in the chain. It's on carbon 2. We're going to give it the lowest possible number as usual. So 2-ethoxyhexane. So thanks for watching, folks. I know that especially the ethers can be a bit confusing. So take another look. Let me know if you have questions, and we'll see you on the next one.